As you can see, we are back to the normal distribution graph. In this particular case, I've been looking at matchboxes. How many matches do you find in the box? And when I measured, the mean was 80 and the standard deviation was 3. So sometimes you find a bit more in them, sometimes you find a bit less. That has to do with the packing. So I've drawn this normal distribution graph. And the questions that we are asking then, okay, if I take a matchbox at random, what's the probability that there are between 75 and 84 matches? Now, it can be any two numbers, but in this particular case, I used 75 and 84. So I'm actually wondering, what is the probability within that shaded area that I have between 75 and 84? Now here we do not have the mean minus 1 time the standard deviation or 2 times or 3 times. So you cannot calculate it or just see it from the graph. In this particular case, we are going to use the calculator. So I'm going to the calculator and show you what you need to do. Here I have the calculator. Put it on. And I'm going to distributions. So here, second, distributions. When I click on that, I see the normal PDF and the normal CDF. You will never use the normal PDF because that's a point on your graph. We will always use the normal CDF. That is coming from cumulative. We add it up. So we add it up to get an area. So let's go to number 2, the normal CDF. They are now asking you what is the lower bound and what is the upper bound. It's 75 is my lower bound and my upper bound is 84. The mean I used was 80 and the standard deviation was 3. When I now calculate, I get 0.861. So 86.1% of all my boxes, matchboxes, they will have the number of matches between 75 and 84. Now, of course, you can take any boundary between with any of the numbers, but let's look at a few more. Let me take away again the calculator. Let's look at what about the probability that the matchbox has less than 75 matches. You will be unhappy because you expect 80, but there are only less than 75. Again, go back to the calculator. Second, distribution. Normal, CDF, don't forget. Now, what is my lower boundary? My lower boundary is very, very small. This graph will continue forever. So usually I will say, let's take minus 1 times 10 to the power, where is my power? 99. That is a very, very, very small number. And my upper bound is 75. The mean and the standard deviation are still the same. Let's see if I use the right minus. Yes. So 0.048% of my matchboxes, they have less than 75 matches. That's not too many. Lastly, let's look at more than 84%. So what matchboxes have more than 84%? Again, let's go back to the calculator. Second, distribution, normal CDF, enter. Now my lower boundary is 84. And my upper boundary is very, very big. So I'm going to use 1 times 10 to the power 99, a very, very big number. The mean and the standard deviation is still the same. Let's paste and see. So I get here 0.091. So 9.1% of my matchboxes will have more than 84 matches, which is nice because I have a few more while I pay the same. So looking back at the screen here, 4.7% of my matchboxes, 4.8%, will have less than 75 matches, and 9.1% will have more than 84. So for any boundary within your normal distribution, you can calculate what percentage or what probability you have to be in that region. If you would go slightly further, you would say, okay, suppose I have 3,000 matchboxes. How many of those will have more than 84 matches? Now we know that the probability is 0.912222, 112819, and I have 3,000 matchboxes. For each one, I have that same probability. Why is it? Let me use the screen here, and let me use the answer that I got from before. Enter. Oh, sorry. Let me redo it. 3,000 times the answer, and the answer is here. And I would find 273, 274 of those matchboxes that would have more than 84 matches. So an easy way, again, draw the graph, sketch the graph, the normal distribution graph, put the boundaries, and then use your boundaries for using in the calculator. If you need a very small number, use -1 times 10 to the power 99. If you need a very big number, use 1 times 10 to the power 99. That will do it. So I'll give you some exercises to see if you got it.